Hi there, in this video we're going to learn about hydroboration oxidation. Let's go ahead and fill in the products. We'll do the first one together so you can try the rest on your own. It's easy to get overwhelmed at first because, let's be honest, there's a ton of reagents on this arrow. You got BH3, THF, H2O2, and NAOH. But all you need to do when you see these reagents is redraw the structure, break that double bond, and add an alcohol group to the least substituted carbon. Because the alcohol adds to the least substituted carbon, we say that this is an anti-Markovnikov reaction. Now, take a moment to try the rest on your own. And if you did them correctly, your answers should look like this. And I want to take a moment to point out that number 3 has H2O instead of NaOH, like the ones above it. And that's okay, both will give rise to the exact same product. Now, you must be scratching your head and asking yourself what the hard part of this reaction is. All we had to do was break our double bond in each scenario and add an alcohol group to the least substituted carbon. So we have to note that this reaction gives rise to what we call racemic products, which means both the enantiomers will form in our products. So this alcohol can either be drawn on a wedge or on a dash. Essentially, both products would form. And we call this a racemic mixture, because these two guys are enantiomers of one another. So take a moment to redraw the products of number 2 and number 3 as a racemic mixture. Now, if you've been paying attention, you might recognize that one of our products is not chiral, meaning it doesn't have chiral centers. Which one of these products has no chiral centers from number 2 and number 3? The answer is number 3's products do not have chiral centers. These carbons here are not chiral, and that's because they have 2 hydrogens. Remember that to be a chiral center, you must be attached to 4 different groups. Because these carbons have 2 hydrogens, they are not attached to 4 different groups, since 2 of their groups are the same. Therefore, these are not chiral compounds. And so it doesn't matter if we draw their alcohol groups on a wedge or a dash. Essentially, this is the same product. And so we could just resort to drawing our product like this, since this right here is not a chiral carbon. In contrast, these carbons are all chiral here, because they're attached to 4 different groups. Lastly, I want to point out one more thing. If the alcohol joined the least substituted carbon, something had to join the other carbon, because remember, there was initially a double bond here. And if that double bond broke, that meant that something had to go here and something had to go here. Otherwise, this carbon would only have 3 bonds. So what joins this carbon is actually a hydrogen. So we have a hydrogen here. And if the alcohol group is going to be on a dash, then the hydrogen is going to be on a dash as well. And we call that Syn-Addition, meaning the 2 groups add from the same direction. If we draw on the hydrogens for all these products, we can see the Syn-Addition more clearly. So we see here that in whatever direction the alcohol adds, the hydrogen adds in the same direction. That's what we mean by Syn-Addition. If for whatever reason you had a reaction where the alcohol added in one direction and the hydrogen added in another direction, we would have called that anti-addition. And you're going to see reactions like that. So if you get a multiple choice question that asks you by what addition does hydroboration oxidation proceed, you would say that it proceeds by Syn-Addition. It's a little chaotic to write out the hydrogens like this, so we'll go back to the way it was before. Last but not least, I want to mention one more quick fact. The stuff above the arrow, BH3 THF, refers to the hydroboration portion of the reaction, whereas the stuff below the arrow, H2O2 and NAOH refers to the oxidation step of the reaction. Now I'm going to leave you with some good news. 99% of professors don't care for you to know the mechanism of this reaction, since it's super long and complicated. But I would double check and ask them to be sure. So that's it for this video. If you liked it, please leave a thumbs up and feel free to subscribe. Happy studying!